Hello everyone, welcome to the YouTube channel of Coral Labs. In this video, we'll look at the post-quantum token-based authorization in the 5G core. We know classical JWT token are used in OAuth 2.0 protocol in the 5G core, which starts with NF service consumer requesting JWT token and NRF generating classical tokens all the way to the validation of it, followed by the services between consumer and the producer. So in this flow and framework, we use JWT token, which looks something like this. It consists of three parts: header, payload, and signature. Within the header part, you can actually look at the algorithm name. For example, in this case, it is written RS256, which is RSA based, and in some cases, you can also use elliptic curve cryptography. In both the cases, the algorithm that will be used is not secure against quantum attacks, making the classical tokens and OAuth 2.0 protocol in 5G core not secure against quantum attacks. So what we need is post-quantum tokens. So this is post-quantum OAuth 2.0 in 5G core. It uses post-quantum tokens signed by MLDSA, which is NIST standardized post-quantum signature algorithms. So these two are the flows. In the first flow, it includes SCP, which includes the post-quantum token request to the SCP, which then forwards to NRF. NRF, working as the authorization server, generates post-quantum JWT tokens signed with MLDSA using its post-quantum private key. And then in response, it gives the token back to the SCP and is then forwards back to the consumer. And then the service request starts, and then finally the post quantum token is validated by the producer using the NRF's public key, and then the services takes place. Similarly, it can be done excluding SCP directly with NRF, in which the flow is same. And in this video we'll take care of this flow, and in the next video we will look at the post quantum OAuth 2.0 in 5G core using SCP. Now let's head to the terminal. So before starting 5G core, let's check the values whether the PQOAuth is turned on or not. For this, we are using this values.yaml file. Right now you can see the PQOAuth option is set to false. We'll change it to true, and then we'll save this file. And now we will start the deployment of the 5G core. So this deployment will take few minutes. We will skip this part. Okay, now the 5G core is deployed with the PQOauth option turned on. Now let's check all the pods. All the pods are up and running. Now let's look into the NRF logs to see whether registration is done or not. We will run the kubectl logs command. So these are the NRF logs. On top of PQOauth, we have also used PQMTLS for the registration as well as for the communication to be quantum safe. So for this, we are using post-quantum algorithms. For example, signature algorithms, we are using MLDSA. And similarly, you can use hybrid MLDSA option as well. And similarly, for the curves, we are using MLChem as well as hybrid MLChem. So it says that PQMTLS has been started and running and all the NFs are registered. Now let's try to connect the RAN also. For this, we will look into the AMF logs. So we will once again run the kubectl logs command to check the logs of AMF. So right now you can see the logs of AMF. Here you can also see the post-quantum certificate that was being used while registration with NRF. This is the overall certificates, and you can see the algorithm name also. The signature algorithm we have used is hybrid MLDSA or ED448 dilithium 3. Now we will try running the RAN and perform a connection between AMF and the RAN. So in the logs, you can see handle ng setup request and the ng setup response is there. which verifies that there is successful connection between the AMF and the RAN. Now once again we'll look the NRF logs. So right now the logs are similar only. Now let's try to connect the UE and see what difference does it make in the NRF logs. So we will turn off the airplane mode. So as soon as we turn it off, you can see the 5G signal is there, and you can also run some YouTube videos to check the internet connection. And we can also maximize the quality, and then also the video is running fine. Now let's focus back on the NRF logs. So you can see the logs have been changed, and you can see the post quantum JWT token is there. The overall table is printed. So this is the idea of how a post quantum JWT token looks like. In the header part, you can see the algorithm name, which is ED448 dilithium 3 or hybrid MLTSA. So for different services, we have different token assigned to the different network functions. For example, for NRF discovery, there is service token. Then for NUDR directory registry, we have another token. And you can see the token requester there. There is post message. Then there is message of HTTPS access token request. And this is the token used for this. And similarly, for other token also, there are access token request. So once the access token request will be there, NRF will then sign the token using ED448 dilithium 3 using its private key. And similarly, you can scroll it down to see the other network services, network service consumers, as well as the producers. Now let's look on the AMF side also to see how the service is being performed between AMF. So you can see this is the overall token which is signed through MLDSA, and this was verified using OAuth token using the NRF's public key. So each producer and each consumer will verify their tokens using NRF's public key. So this is how post-quantum token based authorization is done in 5G Core. Thank you.